Hi, my name is Delaney Vandermoor, and today we're going to be discussing the diatomic molecules. First off, what is a diatomic molecule? A diatomic molecule is an element that, when found in its elemental state, forms a molecule made up of two identical atoms. Remember that when an element is in its elemental state, it is not combined with other elements. It exists freely, uncharged, and in its least reactive form. There are 7 diatomic molecules, and they are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. You can also see them highlighted on the periodic table to the right. A few ways that you can remember these diatomic molecules is with 2 memory mnemonics. The first one is more common and is Brinkelhoff, which stands for bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Or you could use the sentence, have no fear of ice-cold beer. When drawing the Lewis structures for these elements, there are different types of bonds. First, we have single bonds, and this is seen in the diatomic molecules chlorine, bromine, iodine, hydrogen, and fluorine. Each molecule has 1 pair of shared electrons and 3 pairs of unshared electrons. Hydrogen doesn't have any pairs of unshared electrons because it satisfies the duet rule instead of the octet rule. Next, we have the double and triple bonds. In the diatomic molecule oxygen, we have 2 pairs of shared electrons as well as 2 pairs of unshared electrons. Oxygen forms double bonds. Then we have nitrogen, which forms a triple bond. It has 3 pairs of shared electrons and 1 pair of unshared electrons. Now we will discuss the intermolecular forces that are involved in diatomic molecules. You may have noticed that as you go down the periodic table, the states of matter change. Chlorine is a gas, bromine is a liquid, and iodine is a solid. This is due to the number of electrons. As you move down the periodic table, there are a greater number of electrons for the elements. With more electrons, the elements have greater polarizability and form stronger bonds between the molecules. With stronger intermolecular forces, the bonds formed are harder to break, which makes the different states of matter, from gas to liquid to solid. Now, we'll look at the diatomic molecules in a chemical equation. We will use the formation of liquid water from hydrogen and oxygen gas. We'll need to balance the equation. In order to do that, we'll add a 2 in front of the water on the product side to balance out the oxygens in the equation. Then, we will add a 2 in front of hydrogen on the reactant side to balance out the hydrogens in the equation. We are left with a balanced equation of 2H2 plus O2 yields 2H2O. Don't forget that when you use diatomic molecules in stoichiometric equations, you must double the mass that is seen on the periodic table, since the elements occur in pairs. Hopefully, from this video, you have learned what the 7 diatomic molecules are and how they are written, as well as how to use them in Lewis structure diagrams, chemical and stoichiometric equations, and with intermolecular forces. Thank you for watching.